Today we will be talking about all these things which are written here. How do STP works? What are the different types of spanning tree? The spanning tree port states, the interview questions, and how to answer the STP questions in exams. So basically, we are going to have a deep dive into the spanning tree protocol. Root bridge election. Finding out the root bridge is the most vital part of spanning tree protocol. Root port election, which is finding the interface which can help you reach root bridge in the lowest STP cost. So we can talk about now timers in spanning tree protocol.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So let's get started now. So this session is here organized for you, everyone. For spanning tree protocol, we'll be discussing about spanning tree today in very detail. We'll be talking about from very basics to some advanced level understanding of spanning tree protocol. So let's get started. I just want a thumbs up if I am clear and my screen is visible to you all. Okay, perfect. So in the first phase of this webinar, I'll be explaining you the processes related to spanning tree protocol. We'll be sharing some information and details related to the STP. Then after that, we will try out some questions to check our understanding over the protocol. So let me share my other screen and then we will begin. Okay, I hope my screen is visible to you all. So again, welcome to webinar. Today we will be talking about all these things which are written here. How do STP works? What are the different types of spanning tree? The spanning tree port states, the interview questions, and how to answer the STP questions in exams. So basically, we are going to have a deep dive into the spanning tree protocol. Let's get started and let's see what is spanning tree. So we know that a good network is something which includes efficient flow of packets, right? We consider a network as a good network which can transmit our packets very efficiently. But that is not enough for any scenario. Your network should not only be able to transmit the packets efficiently, it should also be able to recover from the faults. It should also be able to, we can say, recover from the link damage. Let's say you have a topology which is connecting around 5 devices. Now these 5 devices should be able to transmit the packets very easily between each other. That is the first priority, obviously. But secondary thing is to make sure that in case one of the link goes down, then there should be something which can help the devices to communicate again or to reach out to each other again. Now these types of topologies are called redundant topologies. When we talk about redundancy, it is all about having an alternate connection. So for example, let's say I have a switch here. Let's say this is my switch. Now my switch is connected with another switch like this. This is my switch number 1. This is my switch number 2. There is no redundancy between them. There is just a single connection. And if this connection goes down, then there is no communication between both the devices. Now let's say I add another switch and I connect it with switch number 1. This is my switch 3 and I connect this switch with switch 1. Then I also make a connection with switch 2 also. So here I can observe a redundancy. If my switch 1 wants to communicate with switch 2, then the first way is going through the direct connection and the other way is going through the switch 3's connection. Okay, I think people are not able to see the screen. I'll reshare my screen, guys, just a second. Is it visible now? Please give me a thumbs up. All right, perfect. Okay, so that's how a redundant topology looks like. Now, do we have anything related to layer 3 also? Yes, we definitely have such things in layer 3. So for example, if I am having a scenario where I have a router 1 connected to router 2, connected to router 3, and then these two routers are also connected like this. Let's say we have a topology like this. Now there is redundancy between them, but this redundancy will be taken care of by the routing protocol. Routing protocol learns about the alternate paths and keeps them as the backup. So in case the first one falls, or we can say if in case the first one fails or gets disconnected, the other one comes up and gets installed into the routing table, right? We all have learned this, and we have been observing this in EIGRP, OSPF, and such things, right? Now, that is not the scenario in layer 2. In layer 2, either you will not have any redundant link, or if you are having any redundant link, then all the links will remain in upstate. Now, this brings in the problem of creating loops. Now, what is loop? Loop is simply revolving frames, we can say the continuous revolving frames within a given topology. So if my data keeps on revolving between these three switches, then that is a basically loop. Now, if I am bringing redundancy, then there are also loops. And if I want to avoid loops, then I have to remove redundancy. So I need to find out something which can help me in such scenarios, which is basically your spanning tree protocol. Spanning tree protocol is there, which can help us in such scenarios by blocking one of the link and making sure that it comes up only when there is a link damage somewhere else. So that's how spanning tree protects us from loops, as well as also provides us the feature of redundancy. So in this scenario, one of the link will be turned off. So for example, let's say this interface of switch number 1 will be turned into the blocked state. After that, the switch 1 has only one path to reach switch 2, which is via switch 3, right? And switch 2 also has the same path to reach switch 1. Similarly, switch 3 has one path to communicate with switch 1 as well as to switch 2. Now, in this scenario, there is no chance of having a loop of data, right? But what if this link goes down? What will happen in that case? Does this redundancy help me in making sure that my network recovers from that? Then the answer is yes. So in case one of the other link goes down, for example, this one, then this blocked link will be turned into forwarding link. And we can say basically this link between switch 1 and switch 2 will come up as an active link, and the communication will go through this particular channel as well. That is what spanning tree is there for. Now, this decision of finding out that what particular port we should block or what particular switch should be forwarding the packets, or what other decisions are there, whatever their decisions are. So all this happens through a series of processes. So there are multiple elections which take place inside the spanning tree protocol, and through those elections, these devices decide that what particular port should be kept in the blocked state or what particular port should be kept in the forwarding state. So let's get started and let's understand what these elections are. So the very first thing from which spanning tree begins is your root bridge election. Root bridge election. Finding out the root bridge is the most vital part of spanning tree protocol. In case you are trying to manipulate things, then the placement of root bridge election is the most important part. Now, what is root bridge? Root bridge is basically a boss of the topology or a master of the topology. Once we elect a switch as the root bridge, then we can say all the configurational BPDU, we will be talking about what BPDU is, will be sent by that particular root bridge. So basically, if I become root bridge, I am going to be the one who will make all the decisions. So the election of root bridge happens through bridge ID. So we elect root bridge with the help of, by looking into the information related to bridge ID. What is bridge ID? Bridge ID is a combination of bridge priority and MAC address. Bridge priority and MAC address. Now, priority is a value of 2 bytes and MAC address, we all know, is a value of 6 bytes. And together they make the bridge ID of 8 bytes. So the bridge having lowest bridge ID will become root bridge. That is the only thing which we have to look into when we talk about root bridge election. What is bridge ID? Bridge ID is your bridge priority and MAC address. So the switch having lowest bridge priority becomes root bridge. Now, what is bridge priority? Bridge priority, which is a part of bridge ID, is by default 32768 for your switches. So in this scenario, let's bring in that triple switches scenario where we had switch 1, switch 2, and this switch 3. So in this scenario, if we haven't manipulated the bridge priority of any particular switch, then that value is going to be 32768 by default. So in this case, switch 1, switch 2, switch 3, all the three switches will have the priority of 32768. So how will we select the root bridge then? Because we have just learned that root bridge election is done on the basis of lowest bridge priority. But in this case, all the all the switches are having the same priority, which is the default, the 32768. So how do we elect them? We elect in such scenarios on the basis of lowest MAC address. So when your switches have same, or we can say whenever there is a tie between bridge priorities, then the election is done on the basis of lowest MAC address. So we can see that switch 1, switch 2, switch 3, all of them has the default priority of 32768. Therefore, we will start looking into their MAC addresses. Now let's say, for example, 1111 is the MAC of switch 1, 2222 is the MAC of switch 2, and 3333 is the MAC of switch 3. This is just an assumption. That's not how your MAC addresses looks like. Now in this case, we have the same priority on all the three switches. These are the MAC addresses. What do you think? Which particular switch should become root bridge according to the explanation which I have just given? Any guesses? Perfect. So we got the answer, switch 1. Switch 1 will become the root bridge here because of having the lowest MAC address in this scenario. Now, can we manipulate the priority value also? Yes, we can set the priority value within the range of 0 to 61,140. That is 61,140. So we can set a value between this range, but we have to make sure that it should be a multiple of 4096. So we cannot go on a switch and go and set the priority of 100 or 200 or 150 or anything. It should be a multiple of 4096. That means if I want to set a priority, then it either should be 4096 or 8192 or so on, like that. That should be the case when you are setting your priority values. So again, let's get back to the example here. I said that we have the default priority. Let's forget about that. Now let's say we have the priority value for the switch 3 as 32,768. For switch 2, it is 4096. Then for switch 1, it is 8192. Now, what do you think? Which particular switch will become root bridge here? Switch 2, right? And the reason behind switch 2 becoming root bridge is having the lowest priority value. So if we are having the lowest priority value, then there is no chance of any discussion over the MAC address. We are very clear. We have the lowest priority value. That means we are the root bridge. That's it. No worries. Nothing. No need of looking into the MAC addresses. But if we are having a tiebreaker between the priority values between these three switches, then in those cases, we can say MAC addresses would be required to make the decision. Now, before the election, every particular switch will be generating BPDU. BPDU is exchanged every 2 seconds among these switches, and BPDU stands for Bridge Protocol Data Unit. Let me write it down here. So BPDU is exchanged between the switches, which stands for Bridge Protocol Data Unit. And these are exchanged every 2 seconds. Now we have learned few things, that the lowest priority will make any particular switch as the root bridge, and the default priority is 32768. If the priority value are same, then the MAC address will be taken into consideration. And after that, we can say we can only set a priority with the multiple of 4096. We cannot set it anything randomly between 0 to 61,140. It has to be a multiple of 4096. Now, after I have become root bridge, I will send out configurational BPDUs. Now these are sent for defining what particular decision should be taken into the topology. So I said I was the boss, right? So I am going to tell everyone that what they are supposed to do through configuration BPDU. You tell them that what particular decision should be done, what your timers should be, what other details which we will be learning about later on in the session today, what those details are required to be configured on each and every device which is there in my spanning tree topology. These are few things which a root bridge is responsible for. Now, after we are done with electing the root bridge, we move to the next election, which is electing the root port. Now, root port selection is done on non-root bridges. So, again, I'll get back to my topology. In this scenario, I have elected switch 2 as root bridge, right? So switch 2 successfully became the root bridge. Now I will find out what particular port will become root port on my known root bridges. What are my known root bridges? It is switch number 1 and switch number 3. These are known root bridges, right? In my topology, switch 2 is root bridge, so the other ones are non-root bridges. On non-root bridges, you will find out that what is going to be the root port. Now, root port is basically the port which helps you in reaching the root bridge with the lowest STP cost. I will repeat myself. Root port is basically the physical path, or we can say is the port which helps you to reach root bridge with lowest STP cost. So for example, if I am talking about switch 1, if this particular port helps me in reaching root bridge, which is switch 2, with the cost of 4, and this one helps me in reaching switch, let's say the cost here between switch 1 and switch 2 is 4, switch 1 and switch 3 is 19, and switch 3 and switch 2 is also 4. Now in this case, if I talk about my root port election, then it is pretty simple that switch 1 will elect this interface as the root port. Why? Because it is helping it to reach root bridge with the lowest cost, that is of 4. If it goes through the other way, then the cost is going to be 19 plus 4, that means 23. So the election is simple, right? This particular port will become root port. So a root port is elected on known root bridges, and the root port is basically the port which is helping you to reach root bridge with the lowest STP cost. Now what are the default STP cost? Let's learn about them. So for each and every, we can say, Ethernet interfaces, we have some predefined port cost. Let's learn what these costs are. So the second is root port election, which is finding the interface which can help you reach root bridge in the lowest STP cost. By default, we have some STP cost defined for different Ethernet links. For Ethernet link, we have the cost defined as 100, which provides you 10 Mbps. For fast Ethernet links, which provides you 100 Mbps, the cost is defined as 19. For gigabit Ethernet, where we get 1 Gbps, the cost is 4. For 10 gig Ethernet, the cost is 2. Then for, let's say, 20 gig Ethernet, the cost is 1. These are the default costs which are defined by the STP protocol for each and every Ethernet link. Now, I had this topology of switch 1, switch 2, and switch 3, right? Where we learned that switch 2 became root bridge. Now we have to find out a root port on switch number 1 and switch number 3. Let's assume that all the 3 switches are connected through fast Ethernet links. Fast Ethernet links means that we are having 100 Mbps here, 100 here, similarly here, 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 all the links are fast Ethernet links. So that means the cost here between switch 1 and switch 2 will be 19. The cost for this path will also be 19. The cost for this path will also be 19, because I have just learned that fast Ethernet link is there with a cost of 19. So Let me find out what particular port will become root port in that case. In this case, if I look into switch 1, then I have two interfaces to reach root bridge. The first interface is this, which helps me to reach root bridge with the cost of 19, right? And the other interface is this, where the cost will become 19 plus 19, 38. So it is pretty simple that this interface will become root port. Similarly, if I say that this is 0/1 and this is 0/2, then you guys tell me that on switch 3, what particular interface will become root port? Perfect. So 0/2 will become root port. Again, the same reason, because it is helping us reach the root bridge in the lowest possible cost. So that's how your root port is also elected. Now we will understand that if we can do some manipulations, we can manipulate the cost or not. We'll talk about all that once we get these things onto the packet tracer. So we'll talk about such things later on. After electing the root port, the next election which is done is election of designated port. Okay, designated port, which is also known as DP, is the port having lowest spanning tree path cost on a particular local area network segment. For example, I have a segment here between switch 1 and switch 3. I have a segment here between switch 2 and switch 3. Similarly, switch 1 and switch 2. So the port having lowest path cost will be considered as designated port. Now, there is one thing which you should always remember, that there basically these are some rules. First rule is STP, while assigning the port states, all the ports of basically root bridge will become designated ports. So that is pretty easy and simple to define, that this port and this port, both of them will become designated port. This is the first rule. Then second rule is that between any LAN segment, any port having the lowest cost will become designated port. So let's see what we are left with. We are basically left with a LAN segment, which is this, right? We have a switch 1, we have a switch 3, where we have to find out that what particular port is going to be designated port. Now, what do you guys think? Which particular port, switch 1's port or switch 3's port, will become root bridge? Any guesses, guys? What do you think? This port will become designated port, or this one? The first criteria, Manish, for electing the designated port is cost. The cost the cost which particular interface is providing you to reach root bridge will decide whether it should become designated port or not. Tell me, guys, switch 1 or switch 3? Exactly. So Manish got this. He just said that the cost is same here. So the criteria after that becomes the bridge ID, which is basically the combination of priority value and the MAC address. So going back to the previous page to check the priority values and other things, we can see that in this scenario, switch 1 has the lowest one. So it is pretty easy that this one will become designated port here, and this being non-designated port will get into the blocked state. First criteria is always the cost. If the cost is same, then we can say the lowest bridge ID will be used as tiebreaker. Is it clear to everyone? Any questions, guys? Give me a thumbs up if it is clear to you. So we can say the last is STP blocked port election. Awesome. Now, after this, we will understand about some of the timers which are there in spanning tree. So we can talk about now timers in spanning tree protocol. So there are basically 4 important timers that actually work in spanning tree. These are the hello time, the listening time, the learning time, and max age time. The hello time is the time between each switch exchange the BPDU message. I told you earlier at what particular interval do BPDU messages are exchanged between two switches. Anyone remembering that? Please put that in the chat box. What was the hello timer, guys? Perfect. So we got the answer here. 2 seconds is the default hello timer, which is defined in spanning tree. This timer is basically the timer between 2 hello messages which are being exchanged between these switches. Then listening and learning can be changed by modifying the another timer which is called forward delay. So forward delay is basically impacting the listening timer and the learning timer. By default, the forward delay is 15 seconds and hello timer is 2 seconds. So the forward delay is the time that is spent in listening and learning state. So these are some states of ports which are there in spanning tree. If I talk about all the STP port states, then we get to see first state as disabled, then we have listening, then we have learning as a port state, then we have forwarding, and we have blocked. Disabled is simple, that when the port is disabled or when the port is down. This is represented with DIS. After that we have listening. Listening is represented with LIS. It basically is when your port is only participating in the root bridge elections and cannot learn about MAC addresses. So at this particular port state, your port will only participate into root bridge elections, will not learn anything, right? We know that switch learns about MAC addresses. But if your port is in the listening state, then that means it cannot learn about MAC addresses as of now. Then after that, from listening to learning, it takes 15 seconds, and in learning, we can say it gets the ability of learning MAC addresses. So in learning state, it can participate in root bridge elections and can also learn about the MAC addresses of connected devices. Now, can I say that it can also forward the packets? No, that will happen in our next state, which is forwarding. Forwarding is represented with FWD, and here also it takes 15 seconds to basically move from learning to the forwarding state. And in the forwarding state, we can simply understand through the name. Here it can also forward the traffic, can participate into the root bridge elections, can learn about the MAC addresses. Then at the end we have the blocked, is by default set as 20 seconds. Max time controls the maximum time that a particular switch will wait for moving a port from blocked to basically forwarding. So for starting that transition, it waits for around 20 seconds. If for 20 seconds it is not receiving any hello messages or BPDU messages, then it will begin that transition and your blocked port will become forwarding. And so basically the switch understands that there is some link damage and I should wait for around 20 more seconds. In case if I don't receive anything in those 20 seconds also, then I will make the blocked port into the forwarding port. Now all this can be simply we can say observed by debugging the spanning tree events. We'll try to look into that or for checking how things are working there between these switches. Now we have already talked about the port states. We have blocking state, we have listening state, learning state, then we have forwarding state. After that, disabled is something which is very similar to shutdown, like your port is down. Now we definitely can also change the hello timer and the max age timer, the forward delay timers. But all of this should happen on the root bridge. And root bridge will basically tell everyone, and all the other switches will be understanding that there's some change between the timers. There is some change in the timers and will inherit that change on the non-root bridges. So these are few things related to spanning tree, and that's how basically it decides what particular port is going to be turned into the block state or what things are going to be there. Now let's look at a topology here on packet tracer and let's try to understand the details of spanning tree through that. So I'm again sharing my screen. Guys, I'll be taking all of your questions at the end. Please allow me some time to explain things first. And Priyank, yes, we can observe that by debugging. Okay, so I'll take 3 switches simply. We'll connect a cable between these 3 switches like this. Now these are currently in the disabled state, then now they must be in the listening state. We can check that information also by running the command show spanning tree. We can see that one of it is in the listening state, one of it is the blocked state. Then if I rerun the command, then I can observe that FA02 is now in the learning state. Again, if I do show spanning tree, then still it is in the learning. Okay, let me try it again. Now it got into the forwarding state and my FA01 is still blocked. So by running the show spanning tree command, you can look into some basics of spanning tree. Now currently we can see that this is per VLAN spanning tree. Per VLAN spanning tree is a version of spanning tree which runs with VLAN to VLAN. So if you have 5 VLANs, you can have 5 STP running in between these 3 switches. Now here I can see that it tells me at the first thing, the first thing it tells me about is the root ID. Root ID is the information related to your root bridge. So it is telling you that for root bridge, the priority is 32769. Now, why it is 9? So it is made up of 2 things, the priority value and the system ID extension. So we can see that breakdown here. Priority is 32768 and then system ID is 1. Then it tells you about the MAC address of your root bridge. So it is telling you that the MAC address of root bridge of this topology is 00498861247. Then what is the cost to reach that particular root bridge? It is 19. What port is helping me to reach root bridge? It is FA0/2. So currently we are on switch 0. Here I'll enable the port labels. So we can say that FA02 is the port. This port is helping me to reach root bridge. What is the cost? Cost is 19 because again the links are fast Ethernet links. After that, we can say that the hello time is defined as 2 seconds, the max time is 20 seconds, and the forward delay time is 15 seconds. Then in the section of bridge ID, you will find information related to your local switch. So this information is going to be about this switch, which is switch 0. So again, the priority is 32768. The MAC address is 006047CC E224. Hello time is 2 seconds, max time is 20 seconds, forward delay time is 15 seconds. Then we get to see some information about interfaces. Interfaces here are defined as FA01, which is in the blocked state. The role is given as alternate. So it will only come up when the other link goes down. Then we have the cost of 19. The priority number is 128.1. It has a point-to-point connection. Then similarly for FA02, we have the information here. FA02 is your root port. It is in the currently forwarding state. The cost is again 19. Similarly, if I go to switch 2 and check show spanning tree here, they enable show spanning tree, enter. Now when I say show spanning tree, so I will find the same information, but this time the information in the root ID section and the bridge ID section is going to be same. Why? Because we can see here that this particular bridge is the root bridge. So the switch 2 in this topology is your root bridge and is the one who is taking all the decisions. So I can see everything is defined here, hello time, max time, forward delay time, and all the same things which we just have looked into this switch 0 as well. So let's try to make switch 0 now the root bridge. How can we do that? Anyone? Is it possible to make switch 0 root bridge? And if it is, then how can we do that? Perfect. So with the help of the priority value, we can make switch 0 as the root bridge. So I'm going to go in on switch 0 and will set the port bridge priority as 4096 in this scenario. So I'll go to switch 0. We'll go inside the configuration mode, config T, say spanning tree, VLAN 1, priority. And if I put a question mark here, then it tells you that you can set a priority between 0 to 61440. But this priority should be in the increments of 4096. So I'm going to set a priority of 4096. Let's see what happens after that. After I made the change in the port priority, or we can say in the bridge priority here, we can see the ports are again turning into some different states. This is not yet up. FA02 is also not yet up. FA02 of switch 1 is also not yet up. So this change must be informed like this change must be given to these switches also, right? And in such things where where your particular link fails or any change happens, TCN are used. TCN are basically the BPDU messages which are used for notifying the topology. These are used for informing them about some particular change. So for example, if I say my link goes down here, then a TCN will be sent by the switches to the root bridge that this particular link is down, and please make the required decisions so that we can change the logged port into the forwarding port. Okay, so let's have a look into the show spanning tree details now. When I say show spanning tree, I can see that the MAC address of my root bridge is changed to 0060, and the MAC address of this local switch is also 0060 something something, right? Because now this particular switch is the root bridge, and we can see that both the interfaces are into the designated state, both are into the forwarding state. Similarly, you will find FA01 as the root port for switch 1 and FA01 for the as the root port for switch 2, because now your root bridge is no longer switch 2, it is switch 0. Make sense, guys? Give me a thumbs up if everything till now whatever we have discussed is clear to you. Awesome, great. Now let's try to also look into the commands which can be used for manipulating the hello timer, the forward delay timer, or the max age timer. So this change must be done on the root bridge. So I'll go to the root bridge, I'll go into the configuration mode, and here I'm going to say spanning tree VLAN 1 hello timer. I think this switch is not supporting that. Okay, I'll show it to you on EVNG. I'll show it to you later on. No worries. I have a similar kind of a setup ready on EVNG also. So we'll look into this thing over the EVNG setup. Now, the next thing we are going to talk about is port fasting. So we just have seen that how the switches are changing their states from listening to learning, then getting finally into the forwarding state. Now, all this is required when there is an exchange of BPDU messages, right? When the forward, or we can say when the next device is also a switch. So because there are 2 to 3 switches, they all are generating BPDU messages. So that's why they have to go through all these states. But even when I am taking a PC here, so when I go to end devices, place a PC and connect this PC with the switch here, even this, in this case also, the port is not directly coming up. It is still going through all the elections, right? And there is no sense of having these elections when the next machine or the next device is not generating any BPDU messages. So since there is no generation of BPDU, this particular port should not go through these states. It should directly get into the forwarding state, because we don't need STP there, right? So in order to remove STP working on such interfaces which are connected with your end devices, what we do is we use port fasting. Now port fast is the feature which can be enabled on a spanning tree for the interfaces like this. Here, if we enable port fasting, then the ports will directly get into the forwarding states once they are connected with any particular device. Now let's see how it is done. So the command for enabling port fasting on any particular access port is spanning tree port fast. That's it. It is so easy. Just go to the interface and say spanning tree port fast, and you have successfully enabled port fasting. But we have to make sure that we are not enabling port fasting on ports which are connected to some other switch, because we need spanning tree there, right? So what I will do is I will enable port fasting for the interface FA03, 4, 5 and 6. So I'll go to the switch, hit enter. In the configuration mode, I will select the range of interfaces. So interface range FA0/3 to 6, and inside these interfaces, I'm going to run the command spanning tree port fast. Enter. After this, you will get some logs which defines that port fast should only be enabled on ports which are getting connected to single host, like your computers, your laptops, and should not be enabled on ports which are connected to hubs, switches, bridges, etc. So currently we have enabled it on FA0, 3, 4, 5, 6. Now let's try to connect some more devices. So this one, 3, 4, 5, 6, and let's say 7. Here I will try making some connections now. Now observe this very clearly. The moment I will click this cable or connect the cable to PC1, the state will directly get into the forwarding state. There you go. I'm not sure if you are able to see that. I will disable the labels here. See, it is directly into the forwarding state. It is not going into listening, learning, directly getting into forwarding, because now port spanning tree elections are not happening here. Again, if I make such connections there, it got into the forwarding directly. Forwarding. Now the next connection will be done using FA07. On FA07, we haven't yet enabled port fasting. So what I will do is, when I connect the cable, see, it started getting into the elections. So you can always enable port fasting on interfaces which are getting connected to devices like, for example, laptops, your PCs, your scanners, your printers, all such devices where you don't need spanning tree, you can enable port fasting there. Then with this, we also have another security feature coming in. Now, I am pretty sure that I will not receive a BPDU message from these interfaces, FA0, 3, 4, 5, 6, 7, right? Because they are connected to end devices and they don't generate BPDU messages. But what if some attacker tries to send out some BPDU message for manipulating the topology or for let's say re-electing the root bridge? So in such cases, we can enable BPDU guard. BPDU guard is enabled on, again, similar type of interfaces where you are connected with PC or laptop. So once you enable BPDU guard, if that port will receive ever any BPDU message, it will directly get into error disabled mode. Make sense, guys? BPDU guard is a guard which protects your interface from receiving BPDU messages. So in case if my PC is trying to send me some BPDU message, which is not basically possible if we work through the legitimate manner, but if some attacker is trying to make some changes through that, then we can use BPDU guard to protect us from such things. So how to enable that? Let's learn that also. I'll go to switch, I'll go to interface FA07, let's say 0/7, and here I'm going to say spanning tree BPDU guard enable, enter. That's the command. Now, in case PC4, which is connected over interface FA07, tries to send out some BPDU message, then that particular interface, which is FA07, will get into error disabled mode and will not come up until we manually intervene there and turn it down as administrator, then make it up again as administrator. Now, such things can be checked very easily by running the commands like show spanning tree interface and FA0/7. Then I can use the keyword detail here. There you go. When I use this command, it tells me that you will find the information about BPDU guard here. So it tells you about some things like port priority number, the port cost, and designated route has 4097. Okay, I think link type is point-to-point number of transitions, message forward delay. Let me give it a try over the EVNG. Check. I'll go to interface gig 0/2 and will enable BPDU guard there. Enable config T interface GI 0/2, and I'm going to say spanning tree BPDU guard enable, and show spanning tree interface gig 0/2 detail. See, in this, it is showing it very clearly that BPDU guard is enabled. So in case gig 0/2 receives any we can say BPDU message, then that particular interface will go down right away. Let's see if we can have a representation of that by adding a switch to that particular interface. I'll have to shut it down. So let me first save the configurations here. Okay, let's build this connection with switch number 1. Save. And I will turn on both the switches. Okay, it is going to take a little time to come up. Okay, so basically if this switch is going to send me any BPDU message, then my gig 0/2 will get into error disabled mode because I have enabled BPDU guard there. Now, just like this guard, we have another guard, which is called root guard. Root guard is basically there for protecting your root bridge. So in your spanning tree topology, you have elected one of the switch as root bridge. So we have elected switch 0 as root bridge. But in case if some attacker tries to send a bridge protocol data unit message with a lower priority, then this particular switch will assume that, okay, there is a switch which is better than me, who is sending me superior BPDU messages, and I should not be that means basically I should no longer be a root bridge, right? In that topology, there is someone who is better than me. But you are pretty sure that you want to keep this particular switch as your root bridge. So you can enable root guard in such scenario. So it is a feature of spanning tree that protects your root bridge from losing the tag of root bridge. So how do we enable that? We go to the switch, go to the configuration mode, select the interfaces and say spanning tree guard root, like this. Now this particular root guard has been enabled, and in case someone else tries to become root bridge, then this particular we can say port will move into root inconsistent state and will only come up when the other side is when the other side will stop sending the superior BPDU messages. Till the time it will receive superior BPDU messages, it will stay into the root inconsistent mode. So you can check these details by using the command show spanning tree VLAN 1. Okay, again, I think I'll have to show it to you over the EVNG only. But yeah, so after enabling the root guard, we can have this protection. If you have any questions till now, then please let me know. Sir, could you please repeat? What section do you want me to repeat, Harsh? Root guard? Okay, so root guard is there to protect your root bridge. In case, let's say we have this particular switch as root bridge, right? In case we change the priority, or because of some manipulations, some attacker tries to send out some superior BPDU messages. Now, what is superior BPDU message? A superior BPDU message is a BPDU message which contains lower bridge ID. So if I am receiving a lower bridge ID, that means in my topology, there is someone who is better than me, who is having a lower priority value, who is having a MAC address lower than me. So that means that particular switch should become root bridge, right? That is the criteria of electing root bridges. So when we want to protect our switch and we want that particular switch to remain as root bridge, we can enable root guard there. Make sense now? So if I have enabled root guard on these two interfaces, then even if I receive some superior BPDU messages, then also my switch will remain as root bridge. Is it clear now, Harsh? Perfect. Okay, now I'll get back to this topology. Let's see what is the state here on switch 1. If I say show interface gig 0/2, okay, we can see that currently it is in the error disabled mode. This is happening because of BPDU guard, which we enabled on gig 0/2, right? So since it is enabled with BPDU guard, when it received the BPDU message from this switch, it decided to get into the error disabled mode. Now we can only make it up by manual intervention, by shutting it down administratively, then making it up again administratively. So by saying basically shutdown and no shutdown, you can bring it up again. So let's see, config T, interface gig 0/2, shutdown, no shutdown. It went down. it came up, then it again went into the error disabled state. Why? Questions. Like I want to know why it went again into the error disabled mode. BPDU guard, right? Because the switch is still connected and will keep sending BPDU messages. That's why we can say that gig 0/2 turned again into the error disabled state. But now when I have shut it down and I try doing the shut no shut again, then we can see that the state of the port is up and is not getting into the error disabled state. Now you also have the option of setting automatic recovery, and you can do it by going into the interface. Go to interface gig 0/2 and say error disable recovery tree. Okay, again the command is I think not supported here. Yeah, so we get this option of setting recovering. So basically we get this option of setting automatic recovery of these ports, and you can set a particular time period of interval after which you want that port to come up after going into the error disabled state. So that is how you can also make the process automated. Now coming to the last thing, which is about multiple spanning tree. Multiple spanning tree is something where we, instead of having spanning tree for each VLAN, we create multiple instances. We create an instance and we can make multiple VLANs a part of that particular instance. So between three switches, let's say I want to create two instances where in the first instance, I want VLAN number 10, 20, and 30. And then in the instance number 2, I want VLAN number 40, 50, and 60. Then that is possible only with the help of multiple spanning tree. In per VLAN spanning tree, PVST, we know that root bridge is elected for each and every single VLAN, right? But in MST, the root bridge will be elected for all the instances. So MST does not, we can say, cause a high pressure on the CPU, as we are not having multiple numbers of spanning tree protocols for each and every single VLAN. We are having instance where a group of VLANs can be a part of that particular instance. Make sense, guys? So we will observe that how this configurations can be done. But before that, I want you to understand this topology, and then I will begin asking my questions to you all regarding all the elections which we have learned till now. Okay, so we have 5 switches here which are connected in redundant ways. So spanning tree must be working between them. If I go into switch 1 and say show spanning tree, then I get some details where I can see that the priority again is 32769. The address of my root bridge is 5000, then 0001.0000. All right, then it tells me that this bridge is the root bridge. Okay, so in this scenario, the switch 1 is the root bridge. All right, then bridge ID, the local information about the switch is also going to be the same, and we can see all the details again. All the particular ports which are there on switch number 1 are in the designated state, right? All of them are forwarding and are in the role of designated. Now, we know that gig 00 and gig 01 is the designated port. But we have to find out that on switch 2, what particular port will become the root port? That is the question. So if I try reaching the root bridge from this particular interface, gig 0/2, then the cost is going to be 4 for this path, and then 4, 8, right? If I go from the gig 00, then again it will be something very large. But if I go from gig 01, then the cost will be just 4, right? So if I look into the details of switch 2 and try to find out that who is the root port or which one is the root port by using the command show spanning tree, then we can see that the root port is gig 0/1, which is directly connecting us to the root bridge. Make sense, guys? Then after that, we will look at switch number 3. Now for switch number 3 also, we have a simple understanding that gig 00 is the one which will help us connect switch 1 or the root bridge with the lowest cost. That will be 4. So again, the gig 00 will be the root bridge, sorry, the root port. So let's confirm that as well. So I am here in switch 3, enable show spanning tree, and we can see that gig 00 is the root port. Now you tell me what will be the root port for switch 4? Gig 00, right? Because the cost from gig 00 will be 4 and 4, that is 8. And if I look from the gig 01 side, then it will be 4, 4, 4, that is 12. So since gig 0 is helping us in reaching the root bridge with the lowest cost, that will become the root port. So let's check that. I'll go to switch 4 and check show spanning tree, and we can see gig 00 is the root port. Similarly, for switch 5, it will be gig 00 only, that will be root port. Enable show spanning tree, and we can see gig 00 is the one which is the root port. Then after that, the next selection is of designated port. So I am pretty sure that gig 00 and gig 01, as both of them are designated port. Then between gig 0/2 of switch 2 and switch 3, let's see which one is the designated port here. When I look into switch 2, I can see that gig 0/2 is the designated port and gig 00 is the designated port. So gig 00 and gig 0/2, both of them are the designated port. What do you think is the reason behind that? I'll do one thing. I'll open switch 3 also and show you the comparison between them. So on switch 3, we have gig 0/1 as the designated port. Then gig 0/2 is the blocked port, and gig 0/0 is the root port. What do you think is the reason? Come on, guys, put some guesses in the chat box. It is fine even if we get it wrong. MAC address, right? So we can see the MAC address here is 002 and here it is 003. So switch 2 is the one having the lower MAC address. That's why it is the designated port, and the other side is elected as the blocked port. Similarly, the other elections will also take place in the same manner. And we can say that in switch 4, if I try to show you the states here, then gig 00 is the root port and gig 01, gig 02 is the designated port. But if I look at switch 5, then both of them should be blocked port. Let's see. So gig 00 again root port, gig 01 and gig 02, both of them are the blocked port. Make sense, guys? All right, now we will look at how multiple spanning tree can be configured in this scenario. So few things to learn about multiple spanning tree. As I said, we will create instances and we will make VLANs participate into those instances. Then after that, MST is backward compatible with spanning tree protocol, rapid spanning tree protocol, per VLAN spanning tree protocol. All of them can work with multiple spanning tree. By default, all the VLANs are part of MST0. That is your instance number 0. MST0 is used by STP and we can say PVST. We will try creating an instance number 1 and we will try making VLAN number, let's say 567, a part of that particular instance. Now I'll go to switch 1 to begin with my configuration. So first of all, here in the configuration mode, I have to enable multiple spanning tree, config T, and I'm going to say spanning tree MST, or rather than that, spanning tree mode MST. This will enable MST in my switch. After that, I need to enter into spanning tree MST configuration. So multiple spanning tree configuration mode is there in these switches, in which we have to enter to define some of the things. So for that, we use the command spanning tree MST configuration, like that. And then we need to create a configuration revision number, which will be done using the command revision. And if I put a question mark, you can set anything between 0 to 65,535. Now these are some parameters which are used for making sure that the switches which we are connecting into a particular instance are having the same values. So I'm going to set the revision number as 10 in this case. After that, I need to define a name. We can set a name to multiple spanning tree by using the command name, and I can name it, let's say, CISCO. Enter. Then I will make instance. So this is my instance number 1, and in this instance, I want to make VLAN from 5 to 7 participate. After this, we have to copy the same configuration on rest of the switches. So I'll go to switch 2 now. I'll enter into the configuration mode, spanning tree mode MST, spanning tree MST configuration. The first thing I need to do is I have to set a revision number. Revision number is set as 10. Name I am going to configure as CISCO. Enter. And then I can say I will create an instance number 1 having the VLAN from 5 to 7. Enter. Then I'll also go to switch 3. There it is. And we'll do the same thing. Config T, spanning tree mode MST, spanning tree MST configuration. Enter. Here, the first thing is a revision number set as 10. You have to make sure that you are keeping the same MST name, the revision number, and the instance number. So MST revision number is set as 10. Name is going to be CISCO. Okay, I think I used the wrong name, CISCO. After that, instance number 1, VLAN which I want to make it participate into is 5 to 7. After this, I will have a look into the details. I will not bring these two switches into the scenario, so I'll just keep it down because of having some limited time. And then I'll just check my details over these switches. So I'll go to switch number 1. I'm going to say end, show spanning tree MST. And now if I put a question mark here, then it is asking me about few things. It is asking me for the instance list, which can be 0, can be something else. So if I say show spanning tree, no MST available for instance 1. Okay, show spanning tree MST detail, I think. Yeah, show spanning tree MST detail. And when I run that command, we can see, okay, got this. We are missing on one thing. We haven't yet made interfaces participate into these VLANs. Once we make them a part of the VLANs, we will be able to check the information related to multiple spanning tree running in for these particular VLANs. Or what else we can do is we can make VLAN number 1 participate into instance number 1. So by doing that, you will have all the information here, since gig 0/0, 0/1, all of the interfaces which are connecting all these 3 switches are part of VLAN number 1. So I'll do one thing. I'll make them participate into VLAN number 5. VLAN 6, VLAN 7, and detail. Okay, because of native VLAN mismatch. See, we are getting the details here at the end of the table. MST1 is there, VLANs which are mapped are 5 to 7. Then the address of your bridge here is 500.001.0.0.0. This particular switch is the root bridge for the MST1. So for MST1, switch 1 is acting as your root bridge. Similarly, if I go to switch 2 and again make the interfaces participate into the required VLANs, then we will have such kind of information here also. Interface range gig 0/122. First, it is telling me about MSG0. After that, we can see details about MSG1 is given. The root bridge ID is here, which is about the bridge ID of switch number 1, and the priority, everything is defined here. Then we can see the cost as a different thing, which is 20,000 in this case. So we have to learn this, that for these interfaces, we have some different costs. So for gigabit interfaces, it is 20,000. For 10 gigabit interfaces, it is 2,000. Similarly, for fast Ethernet interfaces, it is 2 lakh. And for 10 Mbps links, which is Ethernet links, it is 20 lakhs. So that's how these are few things which are different in multiple spanning tree protocol. And using multiple spanning tree, just like I have shown you the example by creating one instance, you can create multiple other instances also, and you can make different VLANs participate into that. So let me know your questions about this. Currently, there is just 2 instances, the 0 instance, which is there by default, and then there is MSG1, which we have created. And in MSG1, we can see Gigabit Ethernet 1 and 2, both are participating. Questions, guys? Okay, then let me ask you some questions. All right, so let's begin. So I have some questions ready with me, which I found interesting. So the first question is, how is a bridging loop best described? The first option we have here is a loop formed between switches for redundancy, then a loop formed by the spanning tree protocol, then a loop formed between switches where frames circulate endlessly, and at the end we have the last option as the round trip path a frame takes from source to destination. Let me know, what do you think? Which option do you think is the correct one? Okay, let's try to look at the answer here. Okay, we also have a question by Manish. Manish, it will be 50 seconds only. Why are you adding 2 to that? So good job, guys, whoever answered it as C. So C is the correct answer for this. A loop formed between switches where frames circulate endlessly is a bridging loop, and this can be avoided by spanning tree, right? Now, the next question is, configuration BPDUs are originated by which of the following? So configuration BPDUs, all switches in the STP domain, only the root bridge, only the switch that detects a topology change, or only the secondary root bridge? What do you think? Pay some attention to the word configuration. I told you about 2 types of BPDU, notification and configuration. Configurations, exactly. Configurations are always and will always be generated by our root bridge. So only the root bridge switch can generate configuration BPDUs. So let's look at the answer here. Perfect. It is B. Next question is, what happens to a port that is neither a root port nor a designated port? So the options are, it is available for normal use, it can be used for load balancing, it is put into blocking state, then the fourth is it is disabled. What do you think? What will happen if the port is neither elected as root port nor elected as designated port? What happens to that particular port? C. So it is put into the blocking state. Let's look at the answer. Great job, guys. What mechanism is used to set STP timer value for all switches in a network? Configuring the timers on every switch in the network one by one, configuring the timers on root bridge switch, configuring the timers on both primary and secondary root bridge switches, then the timers cannot be adjusted. B, right? So we just learned that in order to change the timers, we have to make the changes on the root bridge. So let's look at the answer. B, perfect. If a switch port is in the STP state, MAC address can be placed into the CAM table, but no data can be sent or received. Then what particular state is that? Blocking state, forwarding state, listening state, or learning state? The port can basically learn about the MAC addresses, but cannot forward any traffic. So what particular state it is in? D. Let's look at the answer. So yes, the state will be called as learning state. What is the default hello time for IEEE 802.1d? 802.1d is the IEEE standard for spanning tree. Quickly, we just have learned this. Perfect. 2 seconds is the default timer for hello. Which of these parameters should you change to make a switch become a root bridge? Very easy. Switch MAC address, path cost, port priority, or bridge priority. Pay attention to these last two options, port priority or bridge priority. Okay, Priyank is telling it 4 times. D. Perfect. Good job. 4 times to Priyank. Good job, guys. Then what is the default spanning tree bridge priority on a catalyst switch? 0, 1, 32,768, 65,535. Let's look at the answer. Answer is 32768. Good job. What is the default path cost of gigabit Ethernet switch ports? Gigabit Ethernet 1, 2, 4, 19 or 1000? I am pretty sure I haven't talked about 1000 as of now. So we can remove that option right away. So it is 1, 2, 4 or 19. What do you think? Okay, most of the answers are 4. So let's see. The correct option is C. Good job. Where should the spanning tree port fast feature be used? On an access layer switch port connected to a PC, connected to a hub, then on a distribution layer switch port connected to a access layer switch, or a core layer switch port? What do you think? A. Okay, Priyank is saying C. We will not enable port fasting between a distribution layer switch and an access layer switch. No, we don't want port fasting there. We will enable it to the port connected to a PC. So the correct answer is A. That's all, guys. That's all for today. Thank you so much. I hope you guys enjoyed the session and found this informative. So in this session today, we have talked about various things related to spanning tree. Then we also looked into how we can protect our spanning tree topologies by using some protocols like bridge protocol data unit guard, that is BPDU guard, root guard. Then we brought in some scenarios where we tried looking into multiple spanning tree protocols. Then we also had some discussion about all the timers, the port states, and some minor things related to spanning tree protocol. So I hope you guys were able to understand them all. And thank you so much for being such a great audience. I really enjoyed the last section where everyone was putting their questions and doubts and for responding to these MCQs. So thank you so much, guys. That was all from my side. And thank you so much. If you guys have any questions, you can post it in the chat box. So in the case of hub, okay, we have this question. In case of hub, also port fast is enabled. We can enable port fast in the case of hub, but it will not really work there. It will still transmit BPDU. For that, we have to learn a lot more details related to the hubs and how hubs work. So that is a different topic. But yeah, you can definitely explore about that. So yes, we can enable it, but actually it will not stop the transmission of BPDU. Port fast enable for end user devices. Correct, Harsh. That is perfectly correct, that we just have to enable it for the devices which are end devices. Okay, you are most welcome, guys. Thank you so much. I'll just take the leave now. Thank you so much, guys. Bye-bye. Take care.